These doing hydrostatic force against a vertical plane, but I want it to be a different kind of shape, so you can try to visualize what you've got to do. When you're doing the hydrostatic force of the vertical plane, you're doing the integral from A to B. You've got the density of your fluid. You're going to have the acceleration due to gravity, so I'm just going to put gravity. Then you're going to have the depth of the water above where you are. Then you have the area. And the area includes something times dx or dy. So that's kind of what you're looking for to put in every one of these intervals, okay? Gives me enough balance to the book and the... All right, so in every one of these shapes, I guess I'll just go to area is length times width. All right, well, you're going to have a length, your width is always your dx or your dy. Okay? All right, so I'll look at number 5, where we have a circle submerged in the water. The radius is 8 meters, and there is 4 meters of water above that plate, that circular plate. All right, in every one of these, you've got to put an XY coordinate system. And for a circle, you must put your vertex at the origin if you want an easy problem to work. So I'm going to put an XY coordinate system, and I will put my vertex or my origin at the center of that circle, so I can get my X and my Y. And I need to do this to make it easy, and I'll show you why that happens in just a second. All right, so I'm going to be integrating the entire surface here, which means I'm going to be going from this line to this line. I need to integrate that whole thing right there. I know they gave me that the radius of this circle is 8 meters, so I know I'm starting down here at -8, and I'm going up here to +8. So to integrate this, set that up, I'm integrating from -8 to +8. I am on my y-axis, so I'm going to have dy out here, and I'm going to go ahead and put it so that I know everything in here is going to be a y. Okay, because I'm on my y-axis. Now, this is water, and we are in meters. So the density of water is 1,000, and gravity is 9.8, acceleration due to gravity. Now, the other thing that I did, I split this in half. I put my axis so that it's right in the middle, and I'm looking at half of this thing. I'm going to have to multiply 2 times whatever I do. Now I need depth of the water above where I am. How much water is above where I am? So I need an expression for the water. So you can just start by just picking some numbers and thinking about it. This is 0. When y is 0, how much water is above that point? I've got the 8 and the 4. The water is 12 meters deep. All right, when y is 1, if I move up 1, how deep is that water? 11. What if I move down? Because I have to move down on this shape. What if y is -1? How much water is above me now? 13. So what kind of expression can I write with y for the depth of my water? Okay, 12 minus y. Does everybody agree that that's going to work? Okay. The last thing I have to do is an area. I need a length times a width. Well, my width is my dy. When I slice this, these lines represent what I'm doing to find the area. These are changing according to this line right here, which means for my problem, I need to find the equation of this right here, which is a circle or a semicircle. Now you should remember that the equation of a circle that is centered at the origin is x squared plus y squared equal to r squared. In this case, my radius is 8, so this is x squared plus y squared equals to 64. I need to have y's in here. I'm slicing in the x direction, so solve this for x. X is going to be the square root of 64 minus y squared. It's either plus or minus, but I'm just going to look at the positive square root because that's all I'm looking at. Then that is going to be that times that, length times width gets me my area. And if I put this in my calculator, this will give me the hydrostatic force of the water on that circle. Question? Because I have dy here, I have y here, and these are on the y-axis, so I needed to have y's, so I'll solve for x. What else? Okay, I'm going to assume we can put it in the calculator. What I want to really concentrate on is setting these up right now, okay? Pardon? That too? All right, because where I put my axis, I put it in the middle of this creature, so I'm going to have to multiply whatever I do times 2. And I'm also only looking at the positive square root of this shape, not the positive and the negative square root. So I have to multiply 2 times whatever I do. Anytime I put my axis in the middle, I'm multiplying it times 2. Okay, let me go back to, I told you I would try to explain to you why you need the center, you need your axis at the center, the origin at the center of the circle. If you do not put your origin at the center of the circle, then you're going to have to take into consideration the ordered pair where you did put the center of the circle. If you put the center of your circle up there, if you put your coordinate system up here, you're going to have to count down here and get the center of the circle. Then you have to use this equation. This is if your center is not at the circle, if your origin is not at the center of the circle. You have to use this. So I always put my origin at the center of the circle. Okay, let me look at another one. Let me look at number 7. Maybe you'll think of more questions to ask. Number 7 has got, looks like an equilateral triangle. It says this side is 2 meters, this side is 2 meters, this side is 2 meters, and the water is at the top of this thing. Okay, this is where you have a choice about where you're going to put your axis. You can put your axis anywhere on here. What I usually do, and mine is not the only way to do it, or the right way to do it. Mine is just the way that I do this. I usually will put my axis up here, my origin here, and I usually let this side be x because I like my water to be x, on the x-axis. I don't know why, I just do, which means this is my y-axis. This is the origin. I have put my axis in the middle of this shape, which means, again, I'm going to have to multiply whatever I do times 2. Okay? So I'm going to multiply 2 times some interval. Now I need to know here to here. I need to know where I'm integrating, because this is how I'm integrating. I put this in the middle, so the length of this side right here is 1. The length of this side is 2. How can I find the length of this side so I'll know where I'm integrating? I'm going from 0 to something. Use your Pythagorean theorem. Is it, how about square root of 3? Yeah, square root of 3. So this line right here is the square root of 3. That point right there on the x-axis is the square root of 3. These are x's the way I put it, so I need dx out here. All right, once again, I am in meters, so I need the 1,000 and I need the 9.8. That's a given because you're in meters. Now I need the depth of the water above where I am. All right, here is when x is 0. When x is 0, I have no water above me. When x is 1, I have, how much water above me? When x is 1, I have 1 meter of water in front of me. All right, when x is square root of 3, or 1.7 or whatever it is, then that's the depth of the water. So the depth of my water is simply x. And that's one reason I like to put my x-axis that way. Now my area, which means I'm slicing this way again in the y direction this time, because that's with my y-axis. I need the equation of this line. It is a straight line. For the equation of a straight line, you need 2 ordered pairs. This is a point on an axis, and this is a point on the axis. This point is on my x-axis. It is the square root of 3, 0, because it's on my x-axis. This point on my y-axis is 0, 1. To find the slope of the line, slope of the line is y's over x's. 1 minus 0 is 1. 0 minus the square root of 3 is negative square root of 3. If I use y is equal to mx plus b, I know that this is my y-intercept. So the equation of this line is y is equal to negative 1 over the square root of 3x plus 1. This is what goes at square root of 3. In that, because every time I'm slicing into that line, and that is going to be the length of that line. Whatever value y is the length of that line. These are in relation to x, these are relation to x, this is relation to x, and this is x. Question? Do what? Yeah.
Because linear, there's no square root in the formula or the area.
Straight line. Y equal mx plus b. If you don't like y equal mx plus b, you can use y minus y1 is equal to m x minus x sub 1. You've got to find the equation of that straight line. We use square root because up here we had to find the equation of a circle. You got it? Question? Okay, let's look at one, like number 9, let's look at a trapezoid. number 9. Okay, my trapezoid. This side is 4 feet long. The bottom is 8 feet long. The water is right here. Whoops, there's my water. There is 1 foot from here to here. That's 1 foot there, and there are 2 feet right here. Okay, all that's given to me. So I need the hydrostatic force on that end where the water is. Right? I've got to put an axis on here. Y'all with me? I am going to do like I did here, though you don't have to do it my way. I am going to go up here and I'm going to put my axis in the middle, just like I did before. I'm going to cut this thing in half. Again, I like this to be my x-axis. I like this to be my y-axis, but if you don't like that, put your x and y-axis however you want it. The part that I've got to integrate is this part right here, because that's the part that's underwater. I've cut it in half, so automatically I know I'm going to have 2 times whatever my integral is. I'm going on my x-axis, so I know I'm going to have a dx out here. So that much I know without doing any other work, because that's the way I'm setting it up. Okay. Look at your picture. Where am I integrating? If this is 0, what is this number and what is this number according to what they gave me? 1 and 3, exactly. This is 1. They told me there was a foot of space up here. There's 2 feet of water here, so I'm going from 1 to 3. 1 to 3. All right, I'm in feet. So that's US. So I just need 62.5, and that takes care of the gravity and the water and everything. So 62.5 is all I need. Now I need the depth of the water. That's above me. All right, when x is 1, how much water do I have above me? None. That's the top of the water. When x is 2, how much water is above it there? 1. When x is 3, how much water is above it there? 2. What is an expression that I can use to get the depth of the water no matter what x is? About, yeah, x minus 1. 1 minus 1 is 0, 2 minus 1 is 1, and 3 minus 1 gives me 2. So x minus 1. Next thing is your area. When you slice it, this is going to be your length. Your width is your dx. So every time you slice it, the length is y. Well, whatever y happens to be, we need to find an expression for that. So this time you need the equation of this line out here. Just like before, you need 2 ordered pairs. You need this ordered pair on the line, and I would use this one. You ought to be able to find those. No, doesn't matter, because I just need the equation of the line. Just the only thing, it has to be on the line. That's the only condition. All right, can you tell me what the coordinates of this point are? It's 0 something. It's 0, 2, because I cut that in half. All right, this point right here. This is the point on the x-axis. This is the point 3. And since I cut this one in half also, this is 4. So this is the ordered pair 3, 4. So finding the slope of the line. 2 minus 4 is negative 2. 2 minus 4 over 0 minus 3. So it looks like my slope is 2/3. This point right here, 2, is my y-intercept. So y is 2/3 x plus 2. Y equal mx plus b is what I'm using. This is the expression for y that I need in here. And that would give you the value of the pressure on that surface. Plus b, that's my y-intercept. Anytime you've got a 0 as your x-coordinate, that's your y-intercept, so that's my b. Again, if you don't like that formula, use the other one. Y minus y1 is m times x minus x sub 1. Okay, I need you guys to ask me some questions because I don't know if this is making any sense at all. Doesn't matter. Doesn't matter. That's why on your homework for this section, anytime they ask you to fill in these blanks right here, you don't get a grade for this because there are lots of ways to set this up, and they do not set it up the way I do. So you may get it may count you X. If you can just leave it blank. You can type some in there. Doesn't matter. You're going to get a red. It doesn't matter. What matters at this point is this. Now for me on a test, I got to see that. However you set it up. I don't care. You don't have to set it up like me. You just have to set it up. Draw your axis. Label everything so that I know what you are doing. Okay, but again, these blanks don't matter on your test. On your homework. The only blank that matters is that one when it comes time for homework. And you go through their expression on how to work it, they just do it a totally different way. They do Riemann sums and limits, and I'm not going there. Okay, do I need to know? What do I need to do? Do I need to give you a chance to work on your homework for this? Yeah. Yes. Yes. Because when you slice into it, every time you're slicing into that farthest line. And every time I sliced here, I went into that line. Every time I slice here, I'm going into that half circle. So that's what you use. Now if you put your axis different, you're going to have it all. You got to do it, because of what you do. Do I need to do another one? Yes. Okay. Have you looked at one of your homework at all that I could look at? Yeah. You can, and just to say, yeah, you can be trying your homework while I work another one. I will work one more. Yeah.
Once you get through that one, I'm looking at the 8.2, the last one, number 8, the parabolic shape of the ditch.
2 engineers.
Oh, that one.
That's a nightmare.
No, it's not.
I just made it worse than it was, I'm sure.
Yeah. Okay. All right. Before I leave 8.3, do I need to do another one of these? Please. Do you care what shape?
I don't number 6 on the textbook, the half circle.
Okay.
Is that a textbook?
6 out of the book, yes. semicircle, submerged, so that 4 meters of water down there. Okay. Your first challenge is to decide where are you going to put your axis and where is your origin of your axis. Put it at the center of the circle. The center of my circle is on this line right here. And in this particular case, I would set mine up just like normal. I would let this be the X and this be the Y. Okay, that's what I would do. Now, did you slice it in half? When you put your vertex, your origin there, did you slice it in half? Yes. So you're 2 times an integral. Oh my. I've got to go from here to that point right there, which is what? The water is 4 meters deep, so I should be going from 0 to 4. We're in meters, so we need the 1,000 and the 9.8. All right, I'll give you guys a minute, see if you can figure out the depth of the water. By the way, I'm going to put dy out there because I got y's. I have water. I meant x. Sorry. Except not x. I meant y. Anybody want to hazard a guess what the water might be? Joe? That's the, you're doing the area. You're doing the area, which is going to be right. That's going to be right for the area. How deep's the water? I heard 6, no, I heard
4 months.
which one? They're very different.
4 months wide. 4 months wide. Yes.
Why 4 minus y instead of y minus 4?
Because it's otherwise it'd be heavy.
Your water would be negative. You need your water to be a positive depth. Right. 4 minus y, I think I would agree with that. Would y'all agree with that? Okay. All right, then we can jump ahead to get the area, which I believe is what you got. Let's see if you did that right, though. All right, what is the radius of this circle? 6. All of this is 12, so this is 6. The radius of the circle is 6, so the equation of the circle is x squared plus y squared equals to 36. Do you solve it for x or y? Solve it for x. So x is either plus or minus the square root of 36 minus y squared. We're looking at the positive square root. So square root of 36 minus y squared dy. And that should give you the force. Seem easier that time? Okay. But if you have a circle, please put your origin at the center. Please, please, please. Otherwise it's way too hard.